We are almost at the end of Module 1, just this one and one more lesson to go. In this Lesson 7, we will mostly be looking at the recent development of cloud-based infrastructure as a company portal. We will also examine some company policies used in an enterprise network. Welcome to Lesson 7. Can you believe that we're almost done with our first module? Today, we will be covering the design and deployment of an enterprise network. By now, you know that your subject matter expert for this course is Edwin Oda. Edwin is a cybersecurity expert. His specialties include policy and architectural design, data loss prevention implementation, identity and access management, incident response, forensic analysis, and penetration testing. And I am Nina. Now, in this lesson, we will explore design and deployment in an enterprise network. Examine how the extranet uses an enterprise portal to connect employee to their company network, unpack the structure of a company portal and discuss its benefits, and discuss company policy and look at examples. So far in this course, our focus has been company networks and their infrastructure, the physical and virtual design of the network, and how the hardware and software work together to transmit data. We also explored the extranet, and we're going to take a step back there now. We examined the centralized and decentralized structures. You may recall the remote sites. Now, these remote sites connect to the head office via an enterprise portal. So let's start by establishing exactly what an enterprise portal is. Enterprise portals are frameworks that are integrated into an enterprise network used by big organizations with remote users. The enterprise portal gives all the employees access to information and resources. It can be a web-based platform or application-based platform through the use of Java portlet application. Portlets that are pluggable user interface software components managed and displayed in a web portal on mobile devices. It is thanks to these portals, and the internet of course, that employees who are not in the office are able to connect to the company server. Big businesses hold a huge amount of data or information on employee day-to-day tasks and completed projects. The enterprise portal is key to this as it has various features. Big businesses hold a huge amount of data and information on employee day-to-day tasks and completed projects. The enterprise portal is key to this as it has various features. These include single sign-on. Now, a single sign-on authentication process means each employee has to authenticate once on their entrance to the company network, and after that, they will be able to access the company resources for a time period before the session expires. Integration. An enterprise portal can be integrated into a huge database within a company network so that employees are able to connect to a large and different system within the company network. These enterprise networks are integrated into portals, which can be mobile or web-based. Personalization. Now, due to the sensitivity of the data or information held by companies, each enterprise portal is built to specification. Users can be given access based on their role and the functionality of their role within the company. Access control. Companies will be able to control which resources are accessible to employees. The company can limit access to certain types of documents or even services or applications to certain employees within the company network. The system administrator will also be able to elevate user clearance if needed. Organized system and collaboration platform. Now, with the establishment of an enterprise portal, employees will be able to view different hierarchies of data and collaborate with each other on different projects. Centralized search. Enterprise portals have a search attribute, to locate resources within the enterprise network. So an employee is able to locate fellow employees, documents, and even company infrastructure. And then analytics. Now, with an enterprise portal, the company can track and monitor user behavior on the company network. For example, they can see which documents were viewed and downloaded. So let's explore the different components of an enterprise network using the ONAP portal architecture as an example. The ONAP is an open source software platform that produces a comprehensive platform for real-time, policy-driven orchestration and automation of physical and virtual network functions, supporting complete lifecycle management within a company. The components of this system are classified according to 4 criteria: access, framework, applications, software development kit or SDK, and APIs, as can be seen in this diagram. We will break it down and look at each part separately to understand it better. As you can see in this snippet from the diagram, access refers to all those components responsible for access to the enterprise network. These include the portal user, which are the employees using the system, the portal administrator, the employee who manages the network on behalf of the company, and app administrators. This refers to users with access to the application system setting. In most cases, these are often the portal administrator and other IT employees who work for the company. The framework is basically the essential structure of a portal. Now, this diagram shows the communication model of the ONAP portal. Here, components such as the theme or CSS, content-aware menu, and header/footer are all integrated into the web page or the application of the portal. The integration of all these components in the framework makes it easier for employees to navigate around the network. As you can see, this framework can only be accessed after the user has been authenticated and given the authority to view specific company resources. Let's take a look at application, highlighting various features. Access control. Access control is the selective restriction of access to a place, resources, or even to a network. In this case, the administrator will be able to give access to employees based on the access they require to carry out their day-to-day task. Portal UI, user interface. Now, this describes the means by which each employee is able to connect to a network that is either web-based or application-based. Core session management. Each session is tagged with a unique ID to help manage the user's session. It timeouts if the user is inactive for a period of time, which is an added security measure. And of course, access and authorization control. SDK stands for Software Development Kit. The SDK combines a group of tools or components that enable the program or software to work properly. From the illustration, we see that there are many components here, such as collaborative tools, notification, data access, and UI components, all integrating to form the entire portal. And lastly, API, which is the Application Programming Interface. This is a software intermediary that allows two applications to interact with each other on a web-based platform. From the illustration, we can see a stack of applications that interact with each other. With the API, multiple software can be integrated into one single web page. In the previous lessons, we touched on policies that are used in some of the infrastructures in an enterprise network. That brings the question, what exactly is an enterprise policy? A policy is a principle that guides the decisions to accomplish normalized outcomes. Therefore, enterprise policy could be seen as a distributed set of rules used to govern employees using the enterprise network. In the case of an enterprise network, these rules are used to control, orchestrate, and manage the enterprise network. In large businesses, these rules provide the means to create verify policies, identify, and even flag conflicts between policies. These policies go a long way to helping businesses make many automated decisions within their network. Imagine if an employee needs to access a document. Imagine if an employee needs to access a document by 4 a.m. in the morning. She doesn't need to wait for a system administrator to authenticate the session. If she has the appropriate clearances, she will be able to access that document on the network at any time or place. We have already touched on the what when it comes to policies. So let's now chat about why we need them. Enterprise networks usually require policies for many different reasons. So let's just focus on a few. For security, policies make it harder for an intruder such as a hacker or attacker to break into a network. Now, as we've seen in the architecture of an enterprise portal, there are a lot of privileges the hacker will need to obtain before they're able to access the main resources residing within the company network. Form monitoring or reporting. If a user does access any data on the company network, there is a record showing who viewed it, what time the data was accessed. With this kind of information, system administrators can easily identify any suspicious activity within the network. And then lastly, the life cycle of the management of policies within an enterprise is ongoing and infinite. Policies are constantly running within the company network to help with things like automation, as mentioned earlier. Clearly, enterprise policy is a vital aspect of any enterprise network. Policies allow data to be controlled and regulated. The data is accessible to users based on their user attributes, thus ensuring that only the appropriate people are able to see certain documents. Now let's have a look at a policy framework using the ONAP policy architecture example again. We are going to work through this diagram to show you how the policy framework comprises of the entire policy structure or architecture. The policy creation framework includes the Policy Administration Points PAP cluster. These are the components that enables the company administrator to create and edit digital policies on the network. The policy template or model shows the collection objects, which are the sets of items or data. It also shows the analytics or signature that refers to the accounting or verification of the collection of objects. And lastly, the corrective action, which involves the editing of the collective objects or data. Now, the policy classification section involves the grouping of those policy templates into operational, so where a policy will be applicable, configuration, what is needed, and guard, which refers to what security measures are needed. Policy normalization involves the attempt to reduce the amount of policy conflict identified and increase the basic policy validation rates, which helps to keep the automation process going within the network. The policy classification section involves the grouping of those policy templates into operational, so where a policy will be applicable, and configuration, what is needed, and guard, which refers to what security measures are needed. Policy normalization involves the attempt to reduce the amount of policy conflict identified and increase the basic policy validation rates, which helps to keep the automation process going within the network. And then we have policy storage and distribution. As the name implies, refers to keeping a record of each policy running within the company's network and making sure they're all readily available when needed. Now let's look at the decision and enforcement framework. This consists of the service control framework, which shows how policies are enforced within the network. The service controller, a dedicated controller used for enforcing policy when a new inquiry arises. And the DCAE, that stands for Data Collection, Analytics, and Events. Now, these are generated from the policy framework and sent to the service controller via REST APIs, where the cloud controller or OpenStack is stored in the cloud for easy accessibility. You probably already know that there are many different types of policies that apply to an enterprise network. The policies that are adopted would depend on the nature of the business and the type of architecture the business has chosen. Now, the most common policies relating to enterprise networks are an information security policy, a password policy, an access control policy, an acceptable use policy, AUP, an incident response policy, IR, a remote access policy, an email or communication policy, and a disaster recovery policy. So let's take a look at each of these now. Now, before we discuss this policy, don't get confused by the abbreviation ISP. The abbreviation ISP here does not refer to an internet service provider, but rather to an information security policy. The information security policy is basically a set of instructions or rules configured to work on any end device operating in a specific network. Big tech companies adopt the use of information security policies to ensure their employees, vendors, and even third-party users to follow explicit security protocols and procedures while they are connected to their network. Employees clearly benefit from any updated and current security policy used to protect the system. When an information security policy is applied in a company architecture, it enforces the compliances to prevent and mitigate security breaches. The purpose of password policies is to set a standard for the creation and maintenance of strong passwords within an enterprise network. We shouldn't have to advise you not to use a password like password1 or admin, as they are far too easy to guess. The key is to use good, strong passwords and change them regularly. These are just two basic guidelines that you would probably find in a password policy. Access control policies are used by companies to control the accessibility of resources within their network. Many access control policies are based on the standardized policies of the National Institute of Standards and Technology, NIST, and the Computer Security Resource Center, CSRC. Companies drafting access control policies have to consider how to bridge the gap between their physical security and access control within the business environment. Did you know the NIST, National Institute of Standards and Technology, is a physical science laboratory and non-regulatory federal agency within the U.S. Department of Commerce? IT was founded in 1901, and its mission is to promote innovation and industrial competitiveness. An AUP, or Acceptable Use Policy, is used to address limitations and etiquette, or should we rather say netiquette, as this is the modern term for what constitutes as good manners in the technology world. Each employee must agree to certain terms and conditions before being granted access to any of the organizational assets and resources. These policies can be incorporated into an online business using cookies on websites. They can also form part of the recruitment process in which HR drafts various policies and contracts to be signed. Different policies that must be adhered to by the employee. An incident response or IR policy is used within an organization to manage an incident and propose a remedy to the impact of the incident. Now, this policy helps to lay out the entire process of handling an incident, recording every limitation, damages, cost of the damages, and the time taken to resolve the incident, etc. All this information is useful because the company can better understand how their system was compromised in the first place. We will be looking at this type of policy in greater detail when we start covering data forensics. Remote working is greatly encouraged in today's society. Employees can connect remotely to their employee resources regardless of their geographical location. Remote access policies outline the conditions to which an employee must adhere before connecting from a remote network. You may recall that we chatted previously about IPsec. Now, IPsec helps to encrypt and decrypt network traffic between employees, connecting from a remote network to an organization's internal networks. The email and comms policy documents the conditions for communication in general and outlines how employees can use the business's electronic communication media. These policies are typically common in email, blogs, social media, etc. And the main aim of using this policy is to guide employees in their use of the work email. The final policy we're going to mention is the disaster recovery policy. A disaster recovery policy would usually detail the plan for how the cybersecurity and IT team will manage incidents in the case of a disruption. Most large organizations have these policies in place as a sort of safety measure to counteract network disruption during their operation. Now, in the next lesson, the last lesson of Module 1, we'll be diving into a wireless protocol analyzer's lab to show you how traffic can be captured and viewed within a network. Now that we've looked at enterprise portals and common enterprise network policies, let's turn our attention to cloud-based infrastructure, which are basically just an upgrade of the previous infrastructures we've discussed. So what is cloud-based infrastructure? Cloud infrastructure could be described as the components required for operating cloud computing. These components often contain hardware and software resources, storage, servers, and other network resources. Cloud infrastructure is mostly associated with the tools and components required to build a cloud network. For businesses to be able to host their application on the cloud, they will need to have a cloud infrastructure or lease some cloud storage. Cloud computing is made possible by providing virtualization in servers, storage, databases, and networking equipment to optimize the software and business intelligence over the internet. The cloud is an innovative, reliable solution when it comes to scaling a business. So we've just said that cloud infrastructure is made possible through virtualization. As we learned in our lesson on virtualization, this is done by using the hardware resources within the company's network to create automated software with a good management tool. This diagram shows how cloud infrastructure works in two different enterprises. Enterprise 1 is a much bigger company that has cloud infrastructure in place. And Enterprise 2 is a smaller company leveraging off the cloud infrastructure from Enterprise 1. Enterprise 1 is able to host its central POP, or point of presence, on the cloud. POP is a defined point or physical location where two or more networks interconnect to share information. This means that Enterprise 1 will be able to share information with Enterprise 2 and other remote sites and link them all to the internet. An organization will choose a cloud-based service that suits the nature of its business and their pocket. We are going to look at the 4 most common cloud types that are adopted by businesses. They are private clouds, public clouds, hybrid clouds, and multi-clouds. As you can see in this table, there are also 4 main types of cloud services available to businesses. These include Infrastructure as a Service, IaaS, Platforms as a Service, PaaS, Function as a Service, FaaS, and Software as a Service, SaaS. But more about these a little bit later. Back to cloud types. Public clouds are cloud environments, typically created from IT infrastructure for companies that are not owned by the end users. Public clouds are often common in businesses like Alibaba, who typically host products on the cloud for e-commerce purposes. Examples are Amazon Web Services, AWS, Google Cloud, IBM Cloud, and Microsoft Azure. Public clouds can be on-premises or off-premises. Private clouds are when a cloud environment is solely dedicated to a single end user or a company. In these cases, the environment is mainly there to protect the single end user or company's firewall. Private clouds underlie an IT infrastructure using a dedicated and completely isolated cloud network, mostly found in big businesses who can afford it. There are cases where companies privately rent a cloud environment for the business, which means they would have both an on-premises and off-premises private cloud environment. Private clouds can be subdivided into two parts: managed private clouds and dedicated private clouds. Typically, managed private clouds are used by smaller businesses that leverage cloud environments from bigger infrastructures. They use their private cloud to deploy or even configure their own partitioned cloud services, but the entire cloud environment is managed by the bigger infrastructure. Managed private clouds are often the choice of companies with smaller teams of IT personnel. Basically, they help small businesses to tap into the benefits of newer technologies. Dedicated cloud environments are managed solely by the company who uses the cloud environment. A good example is Red Hat OpenShift, which uses a private and dedicated cloud service and is privately managed by the Red Hat organization. Dedicated clouds benefit big companies because they manage the cloud services, so they can configure the environment to best suit their business model. Okay, back to cloud types. The third type of cloud type are hybrid clouds. A hybrid cloud type is a seemingly single IT environment created from high-end environments where the cloud component is connected through local area networks, LANs, wide area networks, WANs, and virtual private networks, VPNs, etc. These hybrid clouds are simply the combination of one or more private clouds or public cloud services together. A hybrid spec of cloud components is beneficial to big businesses in that they enable them to balance the workload between the multiple cloud environments they have running. Multi-clouds are the last cloud type we're going to discuss. They are a cloud environment that consists of more than one cloud space or service. Multi-cloud services can either be public or private clouds. They are a strategic way for companies to leverage two or more cloud computing services to optimize the workflow within their organization. As can be seen here, a good example would be the combination of software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, IaaS, and even function as a service, FaaS models to form one unique multi-cloud structure. As mentioned earlier, these are all the types of cloud services. We're now going to look at these a bit more closely. Cloud services include the hardware, virtualization, storage, and even the software. These services are hosted by companies that have the infrastructure in place and can leverage them to other third-party users over the internet. As mentioned earlier, there are four main types of cloud services: IaaS, PaaS, and SaaS, and lastly, FaaS. We're going to look at each one in a bit more detail now. The term IaaS stands for Infrastructure as a Service, which means the cloud service manages some part of the infrastructure, such as the actual servers, network, virtualization, and data storage through the internet connection. The user can access the cloud space through an application programming interface, API, or through a graphical user interface, dashboard. The user has the ability to lease a portion of the infrastructure. If you look at the diagram, you will see that the application, data, runtime, middleware, and OS are managed by the business operation model. The term PaaS stands for a platform as a service, which means only the application and data is managed by the company. The other components, such as hardware, storage, virtualization, etc., are provided and managed by an outside cloud service provider. PaaS, by developers and programmers. PaaS is preferred by developers and programmers who need cloud space for their application and data without having to build and maintain the infrastructure. A good example will be the use of MongoDB, Firebase, to host cloud application. SaaS stands for Software as a Service. In this platform, the entire service is delivered as a software application that is managed by the cloud service provider. The software is mostly delivered in the form of a web-based or a mobile application. The services can be installed on mobile devices or loaded on a web browser. And the last type of cloud service is Function as a Service, FaaS. This is the use of a computing integrated model that runs on cloud-based containers. The server logic and constraints of data are managed by cloud-based functions, which are in turn managed by the provider of the services. Companies and individuals like developers who use Function as a Service can run, debug, and even build their own application to their own specification, just with the use of cloud functions. FaaS is mostly adopted by new big tech companies like Amazon, AWS, Google, Microsoft, IBM, Oracle, etc. With FaaS cloud services, small companies can leverage from bigger tech companies who already have this infrastructure in place. They would purchase just the cloud function for a lease time period without having to maintain their own infrastructure. Examples of FaaS are AWS Lambda from Amazon, Google Cloud Functions from Google, Microsoft Azure Functions, which is open source, and OpenFaaS, which is also open source. The use of FaaS gives rise to the use of serverless infrastructures in companies. Smaller companies just require the cloud function from big companies to carry out their daily task. A quick digress to check that we're all on the same page when it comes to serverless computing. Serverless computing is simply the process of deploying code for an application software directly into the production pipeline, all with the use of cloud function services. What we mean by function services is basically software running the arithmetic logic of the applications on the cloud. Unlike other models of cloud computing, FaaS gives companies the opportunity not to manage any of the servers hosting their application, but to rather obtain a piece of code that can be embedded into their application. With this piece of code, a developer can instantiate an event from the application to trigger an event or initiate a software on the cloud. The FaaS cloud model is often used in companies where there is a demand for event-driven execution. This is where they only need the functionality of the cloud servers and not the entire server and its processes. Being able to manage services such as databases, access control, etc., all with the use of functions is quite fascinating. Companies don't have to worry about all the overheads. They can push that responsibility to the cloud provider. From this diagram, you can see that there is an instantiation of an event on the cloud model, which triggers a Lambda function on the cloud. Clearly, cloud computing is the modern replacement of the traditional way of businesses using network resources. Here are some benefits to adopting the use of cloud computing services in your business. Cost. Cloud computing eliminates the cost of acquiring expensive hardware and software and setting up your own data center. With cloud computing, small businesses can also benefit by leveraging from big company resources in place. Speed. Cloud computing services are readily available over the internet, enabling businesses to host lighter weight application on the cloud. This increases the speed of accessibility of those resources on the internet. Productivity. The structure of data centers means that there is a lot of computing power generated by hardware and software through the use of virtualization in data centers. Cloud computing greatly decreases the production time it takes to deploy and host an application on the cloud. Reliability and security. Cloud computing offers a lot of data backup and disaster recovery on different and even multiple locations. It is relatively easy for companies to back up with virtualization where every hardware resource is utilized. Dedicated private cloud services enable companies to control different sets of policies on their network. Our final section in this lesson is a look at software-defined networking technology, or SDN, which is basically an architecture that was designed to make a network more flexible and easier to manage. Software-defined networking, SDN, enables a network to be intelligently and centrally controlled using software applications. With this technology, it clearly distinguishes the network hardware control from the data panel within the infrastructure to enable automation and better policy management. Basically, SDN technology separates the hardware control of network devices using data centers, as can be seen in this diagram. A data center is a physical structure that accommodates an organization's hardware and software. It includes routers, switches, firewalls, storage systems, servers, and application delivery controllers to facilitate computing and the storage of resources. With a data center in place, the organization can use overlays and controllers to distinguish between the hardware and the data within the network. So what is the role of SDN in cloud computing? Tech companies like Cisco, Juniper, and VMware have contributed greatly to software-defined networking, where different policies can be configured through an API-C, Application Policy Infrastructure Controller, with APIs making it accessible on both public and private cloud platforms. SDN's ability to separate hardware from data helps to link failure detection on an organization's network. Network detection can be integrated into the hardware to detect any failure, which is important because companies need to be able to detect a failure and recover the failed hardware in order not to have a disruption in their network. Here is a task for you to complete after this lesson. The owner of a small coffee shop would like to extend their services online using a cloud service. He has asked for your advice on which cloud service you would recommend for his business: PaaS, FaaS, or IaaS. Remember to provide reasons for your suggestion. This lesson was all about the design and deployment of an enterprise networking. We started by looking at enterprise portals and examining policies in an enterprise network. Then we focused in on cloud-based infrastructure and finished with a closer look at software-defined networking. At Shaw Academy, we cater for students with different goals. We offer courses for every learning level, so if you're interested in something but you know nothing about it yet, that is not an issue. From knitting to painting and jewelry design, we have something for everyone. Signing up for courses to gain skills relevant to your career is a critical aspect of enhancing it. Explore an area you know at least something about and build on your skill set. If starting your own business is where you want to be, consider our leadership and management, sales, digital marketing, project management, and many other courses to boost your skills and goals and ensure you start off on the right foot. So lesson 7 is done and dusted. We only have one more lesson to complete our first module. See you soon for lesson 8. This lesson was all about the design and deployment of an enterprise network. We started by looking at enterprise portals and examining policies in an enterprise network. Then we focused in on cloud-based infrastructure and finished with a closer look at software-defined networking.